Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is on 1.5, solving equations with variables on both sides. Alright, so, example 1, solving with variables on both sides. Justify the steps in solving 3x plus 2 equals negative x plus 10 by using the properties of equality. So we have our original equation, which we write first. Next, what did they do? Alright, well, it looks like they added x to both sides. What you do to one side, you must do to the other, right? And that is the what? Because remember, if you add something to both sides, it's the addition property of equality, which you can just do POE, property of equality, because what you did to one side, you did to the other. So when I simplify that, what do I get? 3x's plus 1x is how many x's? 4x. Bring down your plus 2. These cancel out, equals 10. Right? Now what? So we just simplified it. We combined like terms, which we just call simplify. What's next? They subtracted 2 on both sides. You see how they're showing that? Which is the subtraction property of equality. Now they're going to clean that up and simplify that. Any number, right? A number and its opposite is 0, it's gone. Bring down my 4x. 10 minus 2 is 8. We're just simplifying that, just cleaning it up. Now to solve this, I have 4x's, but I don't want 4x, I want 1x. And any number divided by itself is 1. So we're going to divide by 4 on both sides. And that's the division property of equality. Now we're going to clean that up. 4 divided by 4 is 1, 1x or x. 8 divided by 4 is 2. So x equals 2. So what's my solution set? 2. In the first step, suppose that you subtracted 3x from both sides. How would the rest of the steps change? Would the solution be different? All right, so in the first step, if we subtracted 3x from both sides, I would have had 2 equals negative 4x plus 10. Then I would have had to subtract 10 from both sides. Negative 8 equals negative 4x, and I would divide by negative 4. And I get 2 equals x. So I get the same answer, but I would be dealing with negatives, right? I'd have to know my, my rules with a negative divided by negative being a positive and things of that nature. So, would the rest of the steps change? Yes, because you would be moving the constants to the left, right? If you're moving the variables to the right, you'd move your constants to the left, and you'd have to divide by that negative. But you would get the same solution. All right. What is the solution set of x equals x? Why? What if you got x equals x? What is x? X is just representing a number, right? So if x was 3, it'd be 3 equals 3. If x was negative 3, it'd be negative 3 equals negative 3. That's true, right? So your solution set would be all real numbers. Right? It'd be all real numbers because x will always equal itself. What statement do you get if you try to solve the equation? So let's try to solve it. Subtract x from both sides. 2 equals x minus x is 0. It's gone. 2 equals 0. Is that true? Does 2 equal 0? No. So this is false. So your answer is no solution. Because there's no number that you can put in for x that'll make this a true statement. There are no numbers that could be plugged into x that would make it true. Like, nothing will ever work, so it's just no solution. Example 2. Justify the steps in solving 3x over 2 plus 7x minus 7 equals 3 times 2x plus 1 by using the properties of equality and other properties. So the first thing they did is they wrote the original. Then they did distributive property, right? Because look, this and this are different. These are both the same. These are different. And I can see what they did was they distributed this, right? Can you guys see that? They used the distributive property. Is that the property of equality? No, it's just distributive property because you're only doing it to one side. Property of equality means you're doing the same thing to both sides, right? Going from here to here, what did they do? They multiplied by 2 on both sides, right? So they're getting rid of that fraction. They're like, hey, I don't like fractions. They bother me, so I'm just going to get rid of it by multiplying everything by that denominator. So what they're doing to both sides is they're multiplying. So that would be the multiplication property of equality, right? And when they do that, it cancels out that denominator. 2 times 7 is 14x, right? Times 7x. And 2 times negative 7 is negative 14. 2 times 6x is 12x. 2 times positive 3 is positive 6. So all they did there is they distributed. Now, what's going on from here to here? Well, these two are the same. That's the same. What's different here is this part, right? So what'd they do there? Aren't they just combining like terms? They're taking 3x plus 14x, they're adding them together. So they're kind of doing the reverse of distributive property, right? Like, aren't they pulling, like they're kind of pulling the x out? Do you guys see how that, they're kind of pulling the x out? So we're going to call that distributive property again. It's like the opposite, it's like the reverse of distributive property, but they still just call it distributive property. They're like undistributing that x. So then they're actually going to combine those like terms. You know how they like to drag it out and kind of give you extra steps? That's just all that they were doing there. Instead of just saying, okay, combine like terms, and they could have gone from here straight to here and just called it simplify. But they put in that extra step just to confuse you. All right, so now here to here, let's see. So what are they doing? This is what's different, right? From here to here. They're subtracting 12x from both sides. So that's subtraction property of equality. Then they're going to combine those like terms. So instead of them doing that reverse distributive property nonsense, they just do it all in one step like a normal person would. So you have 17x's minus 12x's, that's 5x's. Minus 14 equals, and then the same thing here. The 12x and the negative 12x cancel each other out, leaving you with 6. That's just simplifying. They're combining like terms, right? So now, right here, we have a two-step equation. What's the first thing you're going to do? You're going to add 14 to both sides. So that's addition property of equality. Those cancel out. You're left with 5x equals 20. So how do you solve 5x equals 20? What are you going to have to do? We don't want 5x's, we want 1x. So how do we get rid of the 5 that's being multiplied by x? We divide. So we divide by 5 on both sides, which is the division property of equality. And then we simplify. X equals 4. So our solution set is 4. In the example, could the steps have been performed in a different order? Explain. Well, yeah. I mean, you could have worked with fractions if you wanted to. You could have taken care of the constants and then so they took care of the constants and then the number attached to the variable. You really want to do it in that order. So, but you could, instead of moving things to the constants to the right and the variables to the left, you could have done the opposite, moved variables to the left, constants to right, right? You have some leeway as long as you're following the rules. So what you do to one side, you must do to the other. You have to stay balanced. Would performing the steps in a different order affect the solution of the equation? Why or why not? No. As long as you perform the same operation to both sides, the equation will remain balanced. Right? The solution is the value that makes it true. So the order of the steps isn't going to change that. The solution is the solution no matter which way you get to it, as long as you're following the rules. All right, so page 29, practice. Find the solution set for the equation. Use the properties of equality and other properties to justify your solution. So I want you, with your table partner, to quickly try to get this started and see if you're on the right track. Maybe we can, let's do it this way. So here's your original statement. So then do the first step, and then I'll do the first step. So I'm going to give you guys a little bit of time between each step so that you can kind of do the next step and then see if you're on the same page as me. So looking at this, do your first step. Okay, so the first thing I did is I added x to both sides. Addition property of equality. And then I just combined those like terms. I simplified. Some of you might have gone straight to here and wrote addition property of equality right next to this, and that's fine too. So the next thing I would do to solve this, I have to get rid of that minus 3, right? Get rid of whatever's on the same side of the variable that's not attached to it using opposite operations. Then I have 3 x's, but I want 1 x. So how do I get rid of the 3? Divide by 3 on both sides. You can either show it by doing like divide by 3 on both sides and then doing simplify on the next line, or you can do it all in one step. Division, property of equality. So your solution set is 4.
The first step, where's the x coming? Oh, you did that.
I wanted to add this to both sides. I moved it to the left. All right. So on the next one, I'm going to subtract x from both sides. So I would have 3x minus 7 equals 5. I'm not going to show each in-between step on this one. So if I'm subtracting x from both sides, that would be subtraction, property of equality. Next, what would I do? Add 7 to both sides, right? Addition, property of equality. This is without showing all those in-between steps, right? Then I would divide by 3 on both sides. Division, property of equality. So your solution set is 4. So you could either show like the in-between steps that are kind of more optional would have been 4x minus 7 minus 5 equals x plus 5 minus 5, right? And then there would have been a step in here. Then there would have been a step in here. Right? These work type steps are optional. So if you put that next to it would have been subtraction, and this one would have said simplify. If you put that next to it would have been addition, and then next to this would have been simplify. If you put this, that would be next to it, and then next to this would be simplify. You would just have those extra simplify steps if you showed all the work. Does that make sense? So you guys are okay on doing it both ways? The long, drawn-out way versus the quicker format. All right, so let's look at the next one. I would distribute first. Then I would combine like terms. Anytime we're combining like terms, we just call it simplify, right? I would add 10x to both sides, which would be addition, property, equality. So when I do that, I would have 145 equals 20x minus 35. What's next? I want this letter by itself, so I got to get rid of minus 35 by doing what? Adding 35 to both sides, which would leave me with 180. And that was addition, property of equality. Now what? Divide by 20 on both sides. $20 goes in there how many times? So 20 goes into 100 5 times. So this is going to be 9 times. And so that's division on both sides. So division, property of equality. So your solution set is 9. Are we okay? Distribute. Ooh, this one's ugly. You remember foiling? Half of 6x is 3x, half of 4 is 2. X times x is x squared. X times 1 is x. 2 times x is 2x. 2 times 1. Wait, am I doing something wrong? I am. There were no parentheses there. Why am I making things up? I'm so sorry, guys. I added parentheses and I shouldn't have. I should not have done that. So, I'm just getting ahead of myself. Okay, this said x plus 2, and then this was x plus 1, right? Right? So I only need to distribute this 2. Sorry, my brain was just going and running with it and breaking rules because I added parentheses that weren't there, and my brain just went with it. All right, so leave that x alone. 2 times x is 2x. 2 times 1 is 2. You guys with me now? Sorry for getting ahead of myself. All right, combine like, so that was distributive property, right? Now I need to combine these like terms, right? So 3x plus 2 equals 3x plus 2, and that would be simplify. Subtract 3x on both sides, get them together, and I'd have 2 equals 2, right? If I subtract 3x from both sides, they're gone. So now I have 2 equals 2. Is that true? True. So your solution set is all real numbers. Number 5. Find the set of values of x such that 5x minus 9 equals 6. Justify your solution by using the properties of equality. Okay, what's the first thing I'm going to do? So this is like your original, right? What's the first thing I'm going to do? Did I spell original wrong? Original. Don't even go there. Sorry, my brain's still sleeping from the weekend. All right, so I'm going to add 9 to both sides. So I'd have 5x equals 15. Addition, property of equality. Now what? Divide by 5 on both sides. Division, property of equality. So your solution set is 3. Okay, so this is your original. Now I forgot the G. Wow. Don't even. Just here, I'll just rewrite it because apparently my brain is still sleeping. Add letters, subtract letters, you know. It's all the same. Okay. So get my variables to the same side, right? You want to move the 12x here or the 4x here? I don't care either way. What do you want to do? You want to move them to the left or the right? Left. Subtract 4x from both sides. You'd have negative 16x plus 7 equals negative 9. Subtraction, property of equality. Now what? well, no, I'm moving my letters to the left, so I need to move my numbers to the right. So subtract 7. Now what? Divide by negative 16 on both sides. Your solution set is 1. Make sense? All right, so page 31 and page 32 are your homework on this assignment. So make sure that you guys get those done, and have a great night.